Hello, I'm Professor Rad, and today we're going to continue talking about addition and subtraction of fractions. In the last video, we added and subtracted some fractions that had the same denominator, and in this video, we're going to talk about a few problems where the denominators are different. So, as a reminder, Theorem 1 is our steps for adding or subtracting fractions. Last time, in step 1, all our fractions had the same denominator, so we got to skip close to the end. This time our problems will have different denominators, so we don't get to skip. So just as a reminder, if they don't have the same denominator, we need to find a common denominator, rewrite the fractions with that common denominator, and then we add or subtract across the top, and we keep the denominator the same. And then you simplify your answer if possible. So for example, if I had in the last video, we had like 5 nickels and 4 dimes. So in that case, I had to convert nickels into cents and dimes into cents. So that's basically what we're doing here. We're converting our fractions so that they have the same like size piece of the pie, and then we can add or subtract. So for example 1, it says evaluate each expression. That just means find the answer. And then they also want us to give our answer in simplest form. So I'm going to work through this problem in 2 ways. Okay, the first way I'm going to find just the really easy common denominator, I think. And then the second way I'm going to use one of the shortcuts when we talked about finding common denominators. So you can hear me, I'm getting my calculator out to help me here. So the easiest way to get a common denominator is to multiply the 2 denominators. So our denominators here are 18 and 9. So I'm going to do 18 times 9. That's why I brought my friend over here. And that gives us 162. Then, after we get a common denominator, I need to rewrite each fraction so that it has that common denominator. So we have our 5/18 and our 5/9. We're going to multiply the top and bottom by the same number, and we're going to get a fraction that has a denominator of 162. This is our goal that we're doing. So, do you remember how to find the missing pieces here? The way that we're going to do that is you take your desired denominator and you divide it by the denominator you have. So I'm going to do 162 and divide that by the 18, and I get 9. Whatever I get on bottom, I've got to put on top. And then I multiply these 2 numbers across the top, and I get 45. Then we'll do the same thing for the second set. We're going to divide the desired denominator by the denominator we have, and we get 18. Whatever we put on bottom, we've got to put on top, and then we multiply the top numbers. So 5/18 is going to turn into 45 1/62. Oof. And then 5/9 turns into 90 1/62. Okay, so we did this work over here on the side in order to get our common denominator and to rewrite our fractions. A common mistake I see here often on tests, especially if like the answers are smaller, so it might be easier to see something sneaky, but a common mistake I notice is people simplifying this, and you want to avoid that. Do not simplify your answer until the very end when you are adding or subtracting, right? Simplifying is at the end of an addition or subtraction problem. So for our addition, now our pieces are the same size. We're going to treat the denominator like a common unit or a label, so we keep the denominator the same. And the tops we're going to add. So remember, this is like how many things we have, and then this is like how many cents we have, kind of idea. So 45 plus 90 is 135. Whew. Okay. So now we have 135 over 162. We need to simplify this. So let's see if it simplifies. You can use the greatest common factor technique or the repeated division technique. In this case, because I have larger numbers, I'm going to use the third technique of using the prime factorization of each number. And then I'm going to cancel common factors. So for example, since 135 ends in 5, that means that 5 is a factor of 135. And when I divide, I get 27. 27 is smaller and more familiar to me. I know 27 is 3 times 9, and I know that 9 is 3 times 3. Now, if you're not as familiar with your multiplication tables, it's okay. You could just start in with the 27 and try dividing by other numbers, and eventually you'll find 3 and 9. With 162, since it ends in a 2, that means it's even, so 2 is going to be a factor. And then I get 81. 81 is again a number I recognize. That's because 81 is 9 times 9. But again, if you didn't recognize 81, you could go ahead and try dividing by 2 or by 3 and so on till you find one that works. And each 9 is going to split up into 3s. Whew. So I've got my factor trees for my 135, my 162. So I'm going to replace 135 with 5 times 3 times 3 times 3. And then I'm going to replace 162 with 2 times 3 times 3 times 3 times 3. All right. Now I'm going to cancel out my common factors. So 3s, 3s, and 3s. And nothing else will cancel out. So we're left with a 5 on top and a 2 times 3 on the bottom. So we have 5 on top, and then 2 times 3 is 6. Whew. So you can see, especially compared to the previous video, these examples can take quite a bit of time to work through. So what I would recommend is think about the steps that you're doing and separate them out each step along the way. And you want to be intentional. You want to say, well, why am I doing this step? What's my goal? And then how does it fit into the original problem? When I do this work off on the side, this is work that I need to help me in my original problem. But if I put it all over here, it's going to get jumbled and muddy, and I won't remember why I'm doing it. I'm going to start making mistakes and undoing the work that I just did. So I've got my steps in mind. I need a common denominator, and I rewrite them. So once I've got them rewritten, then I can rewrite them on the main problem, and I'm back in the land of addition. After I add, I'm off to simplifying. So I probably should have labeled this step here as kind of my work to start to simplify. So my goal in making the factor trees is so that I could simplify this fraction to get my answer in simplest form. Whew. Okay, now I said we were going to do this example in another way. So, oh golly, let me hit the screen there for a moment and pull out some paper, and let's work through it another way and see if we get the same answer. So we had 5/18 plus 5/9. And the shorter way of going about this one is going to be getting a nicer common denominator. So when we talked about ways of getting a common denominator, we talked about one way is to multiply the two denominators. That's what we just did. Another way is to find the smallest common denominator, and you can use some prime factorization to help you there. But there's another way that doesn't often work, but when it works, it's really nice. And that method works in this instance. That method is when one of your denominators is a divisor of the other one. In this case, I know 9 goes into 18, and I know that 9 goes into 18 2 times. So I can take my 5/9 and multiply top and bottom by 2 to get 10/18. So I can rewrite just the second fraction to get the same denominator as that first fraction. So following along and labeling my steps, this is rewrite with my common denominator of 18. Once I've done that, now I can add across the top. 5 plus 10 is 15. And I keep the denominator the same, 18. Now that I've added, we can go ahead and simplify. And this time, since these are smaller numbers, I'm not going to go find my prime factorization. I know that 3 is a divisor of 15 and 18. So I'm going to divide the top by 3 and the bottom by 3. And that's going to give me 5/6, which is the same answer we found before using the longer method. So when we talked about getting common denominators before, we said that this method of multiplying the two denominators, it always works, it's very direct, but one of the downsides is that it results in really large numbers. And when you have large numbers, your techniques for simplifying are going to take you a little bit longer. Whereas if you notice some of those tips or tricks and take a few shortcuts, then it's much smaller numbers and can take a much shorter time to simplify. Neither of these is better than the other. It just depends on what you prefer and what you see and what sort of approach you like to take to things. For example, me, myself, when I'm first learning about something, I don't care how long it takes me, I'm going to take the most direct route because that's the thing that I can remember. I have a very difficult time remembering lots of different things all at once. So when I first learned fractions, I'm going to do this longer technique. Even though it's longer, it's a method that I know. I can kind of get into the groove of getting the denominators, rewriting, adding, simplifying, answer. I can kind of follow that general path with those longer steps. And then the more of them I did, the more often I would notice shortcuts like this and start to apply them. So if you're somebody who has difficulty remembering all the rules, then I'd recommend taking the most direct approach. But if you identify these shortcuts or you don't mind following, looking for those shorter techniques, then by all means, feel free using the techniques you're comfortable with, right? If you're comfortable with it, go ahead and use it. So that being said, let's do another example together, and this time we'll have 3 fractions. Okay, so this time our 3 fractions are 1/2 plus 2/3 plus 3/4. And all 3 fractions have different denominators. So we want to find a denominator that is common to all 3 fractions. Again, you can use whatever technique you would like to use. I'm going to use a shortcut for this one. But again, if we didn't do this one, I'll show you what the longer way would look like at the end, just so you can compare. But I won't go through all the long steps kind of like I did before. The shortcut is that I happen to know that the smallest common denominator for all 3 of these is going to be 12. And that's because I know 2 goes into 12 6 times, 3 goes into 12 4 times, and 4 goes into 12 3 times. So 12 is going to be the common denominator I'm using. However, if you wanted to multiply all 3 of these and get 24, you could do that as well. It's totally fine. Next, I'm going to rewrite them so that they each have the same denominator. And this time I've got 3 fractions to work with. So 1/2 times something to get 12ths, 2/3 times something to get 12ths, and 3/4 times something to get 12ths. To figure out the something for each fraction, I'm going to do my desired denominator divided by the denominator I have. So 12 divided by 2 is 6. That goes on both top and bottom. 12 divided by 3 is 4. Goes on bottom and top. And 12 divided by 4 is 3. Okay, so to finish this off, I'm going to multiply the top numbers. So 1 times 6 is 6, 2 times 4 is 8, and 3 times 3 is 9. So I rewrote each of my fractions so that they have the same denominator. I'm going to come back to the main problem and write them in their new forms. So 1/2 turns into 6/12. 2/3 turns into 8/12. And 3/4 turns into 9/12. Whew, okay. Now what? Well, I'm not going to simplify, even though I want to. I'm not going to simplify because I noticed these adding signs, and adding means simplify at the end. Wait till the end to do the simplification. So since they all have the same denominator now, I'm going to add across the top. So I have 6 plus 8, which is 14, and 14 plus 9 is 23. So we get 23 over 12. Now, I don't think that simplifies. 23 is a prime number, and so 12 doesn't go into 23. So that's going to be my final answer. Okay, so what I'm going to do now is I'm going to rewrite out this problem as if I had used the common denominator of 24. I'm not going to work through it step by step, but I'll show you my work and kind of explain it so you can see what that would look like if that's a method you would prefer. Okay, so here's my work when I use 24 as the common denominator. So I rewrote my problem down here. So we had 1/2 plus 2/3 plus 3/4. So to get my common denominator, I just multiplied the three denominators together and got 24. And then I rewrote each fraction and got them in terms of 24ths. So I got 1/2 was the same as 12 24ths, 2/3 was 16 24ths, and 3/4 was 18 24ths. When I added them up, I got 46 24ths. And then I noticed that both the top and bottom were even, so I divided them by 2 and got my simplified answer 23/12, which is the same answer we got when we used a common denominator of 12. So again, the only downside to using a larger denominator is that you might have to do more simplifying in the end. Before, we didn't have to do any simplifying after we got our answer. We just added and it was already in simplest form. But that's really it. If you don't mind working with those bigger numbers and simplifying, then go ahead and use this technique since it will always work. All right, so I've got one question for you to try in this video. In the next video, we're gonna work through addition and subtraction using a few different calculators so you can see how your calculator goes about finding these results. Have a great day, and I'll see you next time. Bye for now.